In this video, we're going to take a look at compound inequalities. We'll solve them. These are inequalities that have and or. As I just said, a compound inequality is an inequality that contains two or more inequality symbols. The solution sets will use the words and or. There are two types that we've discussed. This and concept would be the intersection. So an intersection of two inequalities is the set of all elements that belong to both. That would be and. A union, and we use this symbol, kind of a U, between two inequalities is the set of all elements that belongs to either inequality. This would be or. And has both included and uses this sort of upside down U or N. Or is a union, either inequality, anything that is in either inequality. And we'll take a look at each of these in closer detail. First, the intersection. The solution set of a compound inequality formed by the word and is the intersection, again with that upside down U, of the solution sets of each inequality. A and B, set A and B, is the set of all elements that are common to both. And we'll read A intersect B when it's written in this symbol. So A intersect B. And what that means using this Venn diagram is the things that are common to both, and that is found in the center or overlapping situation. Here's one inequality which we will solve, combined to another, using the word and. So we subtract 3 from both sides of this inequality sign. X is less than 5. And x is greater than, x is greater than 2. We will go ahead and graph this. And I'm going to build this, because there are two parts, I'm going to build this above the number line. So first on the number line here is 0, 2, 5. The first one, x is less than 5. This is not or equal to, it's not included, so it's going to have a parenthesis at 5 opening down because it's an upper bound, since x is all of the values less than. So it's opening to the left and shading that direction. And x is greater than 2. So again, not included, a parenthesis, but x is greater than 2. So 2 is a lower bound. Parenthesis opens to the right, and we shade to the right. And, or intersection, is the overlapping portion. That is going to be between 2 and 5, and so what I'm drawing right now on the number line is the actual answer that you would show. This is kind of just work above, but this number line now has appropriate graph. Often we are asked to solve, graph, and write our answer in interval notation, and if you graph first, again look, this lower bound is 2, and that is connected to the upper bound of 5. Both are not included, so here's the interval notation. Really right off the graph, it makes it pretty simple to get the interval notation. Let's take a look at another and example. 2 times x is greater than 0. The inverse of multiplication is division, so we divide by 2. X is greater than 0 divided by 2 is 0. And We're going to add 1 to both sides of the inequality here and have 4x is less than or equal to negative 8. Divide both sides by 4. X is less than or equal to negative 2. You may be thinking to yourself, wait, he did not change the sign, but we divided a negative, so the inequality sign should open in the other direction. Remember from the previous video, we said if we divide or multiply by a negative. So that means this 4 would have to be negative in order for the inequality sign to open in the other direction. So I actually did it correct here. And we now have to graph x is greater than 0 and x is less than or equal to negative 2. So we will go ahead and take a look. 0 is a critical point and one that we're going to actually put over here. One that's important to plot always. And then negative 2 is our other critical point, and that is to the left of 0. Alright, x is greater than 0. It's not or equal to, so again a parenthesis, and 0 is the lowest thing, so it's the lower bound, shading to the right. X is less than or equal to negative 2. This time we have a bracket because it's or equal to. And it is an upper bound, so it opens to the left, and we shade to the left. Again, our x values are less than or smaller than the negative 2. Since this is an AND, or intersection problem, we are looking for the overlapping portions of this graph. There are no overlapping portions of this graph, so the actual graph answer just remains blank. And there is no solution. Example 3 shows a compound inequality that would be an intersection or an AND problem in the more common way that you will see this, where we put them together and say that negative 1 is less than or equal to this expression, and the expression is less than 2. So now we have 3 portions, or 3 expressions, or 3 sides of this inequality that we need to work with. And I'm going to kind of put dotted lines down so that we do not fall into the trap of only working with one set. Often students will just subtract 5 from those 2 sides, forgetting this third side. See, wherever there's an inequality sign, if we're going to do something to one expression, we must do it for all 3 that are separated by each of those inequality signs. So negative 6 is less than or equal to 2x divided by 3 less than negative 3. The coefficient on the x is 2/3. Instead of dividing by 2/3, we're actually going to multiply all 3 sides by the reciprocal of 2/3, which is 3/2. 3 divided by 3 is 1, 2 divided by 2 is 1, and so in the middle we just have x. We did not divide or multiply by a negative, so our signs will stay the same. On the left side, negative 6 divided by 2 is negative 3, times 3 is negative 9. On the right, 3 does not divide by 2, so we will multiply negative 3 times 3 and get negative 9. And in the denominator, 1 times 2 is 2. We'll go to the graph. We have 2 portions. We have negative 9. 0 is going to be here. And negative 9/2. Negative 9/2 is 4.5, negative 4.5, so that's going to be right here, negative 9 halves. The first, it says x is greater than negative 9 or equal to, so a bracket, negative 9 is a lower bound, we shade to the right. X is less than negative 9 halves, so this is a parenthesis, it is an upper bound, and we're shading to the left. Again, parenthesis because this is not or equal to, so this is just a boundary, it's not included in the answer. We're looking for the overlap since this was an intersection or and problem. Where are the values that are greater than negative 9 and also less than negative 9 halves? That's going to be here with a bracket on negative 9, a parenthesis on negative 9 halves. We shade in between the overlapping portion of the smaller graphs we did in isolation above. And now interval notation is easy right from the graph. The lower bound is negative 9, which is included. The upper bound is negative 9 halves, which is not included. Our last intersection example for right now. Negative 2 less than 1/2 x minus 5 is less than 1. Again, this is another intersection question, and we have two inequality signs, so three expressions to work with. We're going to isolate the x term in the middle, so we'll add 5 to all three sides. This is going to give us 3 is less than 1/2 x is less than 6. 1/2 times x, so we're going to multiply all three sides by the reciprocal of 1/2, which is 2 over 1. 2 times 3 is 6. 2 times 1/2 is 1x. 2 times 6 is 12. Our lower bound is going to be 6 because x is greater than that. And the upper bound of this set is going to be the 12 because x is less than 12. So that's our upper bound. Now taking that work, both values, both critical points are not included. So it's parentheses. The shaded region in between is there. So 6 to 12, both not included. There's your answer of the solution set in interval notation. The second type of compound inequality is the OR question, or a union. And the solution set of these it includes elements of either set. The symbol is the U, and we see A union B. That's how we read this, A union B. So it could be anything that is common to both, or just A, or just B. So it's anything in this Venn diagram would be acceptable. So we will include all portions of the answer that we receive or that we get. Let's take a look at example 5. Two-thirds x is greater than or equal to 5. So we're going to multiply by the reciprocal, which is 3/2. And we have x is greater than or equal to 15/2, or negative x plus 10 less than 7. Subtract 10 from both sides of the equal sign. Don't forget to bring down the negative sign. Often that is something that people will forget. This is negative x, and that still is negative x. We've done nothing to that term. is less than negative 3. Now, the x has a coefficient of -1, and we need to get rid of that so that x is by itself. We'll use the inverse operation of multiplication, or of division. And that is then x greater than positive 3. Negative divided by negative is positive, and because we divided by a negative, the negative was in the denominator, the inequality sign changes and opens the other direction. 15 halves is about 7.5. 3, 0, like that. Okay. X is greater than 3. It's not included. X is greater than or equal to 15 halves. So that is included with a bracket. And we shade to the right. Both arrows are going to the right. And this was an OR question. So unlike the first set of problems where we are looking for the overlapping region only, we will be working to find any, or the elements from any set. So because these overlap from the 15 halves on to the right, all of that is included, but so is this. So the actual answer for this solution set will be the x greater than 3. And in interval notation, 3 is the lower bound, not included, all the way to positive infinity. And remember, infinity is not included because you can't put your finger on infinity on the number line. It's more of an idea, not an actual position on the number line. Example 6. Two inequalities joined together with OR. This is a union type problem. So again, not just an overlap if there is, but any portion from either set will be a part of the answer. We'll work with the first inequality here. Add 3 to both sides of the inequality sign. 5x is less than or equal to 13. Divide both sides by 5. X is less than or equal to 13/5. Or subtract 1 from both sides. X is greater than or equal to 4. So as we build, 13/5 is larger than 2, so 0. We're going to put 13/5 here, and then 4 here. X is less than or equal to 13/5. That's an upper bound that is included. We'll shade to the right and use a bracket, or shade to the left and we'll use a bracket as the upper bound on the right of that branch, or that inequality solution set. The other, x is greater than or equal to 4. So 4 is included. It's a lower bound because x is greater. We shade to the right. Again, this is a union or an OR problem, and therefore anything from either is included in our answer. So we're going to take both portions and put them on our number line for our final graph. The interval notation for an OR question when there is no overlap, like the first example, is kind of a little tricky, but not too terrible. We'll start from the left and work all the way to the right, listing anything that is shaded. So negative infinity, again not included, all the way up to an upper bound of 13/5. That is included. Then we use that union symbol to kind of join both solution sets. The lower bound of the next branch is 4, that is included, all the way to positive infinity, that's not included. So we basically write in interval notation both sections and join them with the union symbol, which is that U. Number 7, the inequalities are joined by OR again. This is a union, so anything from either solution set will be included in our final answer. We're going to add 5 to both sides of this inequality and have negative 2x less than 2. And we're going to divide by negative 2. And x is now greater than negative 1 because we divided by a negative 2. The inequality sign will open in the other direction. This OR, we divide both sides here by 6 to get x by itself, x less than 0. So negative 1 and 0 are the critical points, and x is greater than or equal to negative 1, or x is less than 0. I think I just said x is greater than or equal to negative 1. It is not. It is only greater than. So both cases are not or equal to, and therefore I use parentheses in both cases. They're not included in the branch, in each branch in isolation. However, OR, union, we take both and put it together. There is an overlap, which we will include in our answer, but then we also include everything to the left and everything to the right. So even though negative 1, for example, is not included in the top solution set, it is included in the bottom solution set because this shading continues forever. So this is a special case where actually for an OR inequality, it is all real numbers. Before, we wrote that as a capital R with 2 backs for all real numbers in previous videos, but now with interval notation, the better way to write that is again to read right off the graph. Negative infinity to positive infinity, and that includes everything in interval notation. This would mean all real numbers. Any number on the number line. Example 8. This one is a little more complex, but not too challenging. We want to bring the variables on the first inequality to one side and the constants to the other, as we've done in previous inequality solving as well as equation solving. So I'm going to add 2 to both sides of the equal sign, or inequality sign. 6x is greater than 5x plus 5. I'm going to subtract 5x, and we have x greater than 5. Or we'll add 3, and we have 4x less than x plus 3, and we'll subtract x. So 3x is less than 3, divide by 3, both sides of the inequality, x is less than 1. So we'll graph each branch as we build this. I'm actually going to not use this line. I'll draw a new number line here so I have more space to work with. Above we have, let's see, 0, 1 is a critical point, and 5 is a critical point. X is greater than 5, not or equal to, and, or x is less than 1, not or equal to. So parentheses for both bounds. This is a union because of the OR, so we are going to choose all of the solutions from each inequality, and therefore we shade to the right of 5 and to the left of 1. Interval notation, we start again from the left all the way to the right. Negative infinity to 1, both are not included. Union 5 to positive infinity. There is the interval notation answer to this solution, or to this inequality.